Good afternoon, everybody. Just let me know if you all can hear me, please. All right, cool. You all saying you can hear, right? Let me just check something here. All right, so let me get started here. All right, so in this video, what I'm going to be looking at, I'm going to be looking at some questions pertaining to trigonometry, geometry. I just wanted to do this particular question here on a cumulative frequency curve, right? Within recent times, I've noticed that CXC, their questions are slightly different in terms of what they typically bring, right? A typical question on cumulative frequency curve, they would allow you to plot a curve, right? In this particular instance, they wanted us to work backwards, right? So we have, in this case here, a group of 100 students, and they estimated the mass of a seed, right? And the cumulative curve shows the results, right? I think this was I believe it's January 2020. I believe so, right? Now, they want us to use the cumulative frequency curve to estimate first the median, right? Now look at this curve here. This is what we call a cumulative frequency curve. The shape of this curve is what we call an ogive, right? I've seen them ask this in the multiple choice already, right? That's the name of this particular shape that a cumulative frequency curve looks like. Now, so we have cumulative frequency curve is on my vertical axis, and in this case here, we have mass of the seed in grams on my horizontal axis. So the first thing I want you to do is to determine the median, right? Now we have 100 students, so you realize the cumulative frequency curve goes up to 100, right? Now the median is actually my middle, right? So in this particular case, in order to find my median, all I need to do is to find half of my total number of students, which in this case is going to be 50. And then what we're going to do, we're going to go across here on my graph, and then we're going to come down, right? So when we come down here, if I can read this all properly for you guys, right? So this works out to that is about 3.2, right? So my median is actually 3.2 grams, right? That's essentially what it is. Give me a sec there, guys. I just want to adjust something here. Right. Now the next thing that they want us to do, they want us to find the upper quartile, right? Now, when we are dealing with cumulative frequency curves, we have what we call our lower quartile, which is a quarter of our data. We have the median, which is half of our data, and we have our upper quartile, which is 3/4, right? So typically, now in this case here, it's 100. So a quarter of 100 is actually 25, right? And so let's look at that. So Q1, right? That's what we call our lower quartile, right? It's called our lower quartile. And that's essentially what we need to do is to read off a quarter of our data, right? In the case of Q2, Q2 is what we call our median, right? And that is actually a half of our total data. We're going to read off from the graph. And then we have Q3, which is our upper quartile, right? Which corresponds to 3/4 of our data, right? So in this case, we want the upper quartile. We want this. We want Q3. So 3/4 of 100 is actually 75, right? So what we're going to do, we're going to come across here and we're going to read off 75. We're going to come across until we reach a curve. And then we're going to come down and actually read off this value here. So based on that here, I am getting, that's about 4.2, let's say about 4.3 grams, right? Probably around there. So you all need to be able to look at these curves, right? And be able to read off these values here. Right, so it's about 4.3. The next thing they want us to find is our semi-interquartile range, right? Now, there's a formula to find what we call our interquartile range. So interquartile range is simply my upper quartile minus my lower quartile. My interquartile range, right, is equal to Q3 minus Q1 divided by 2. That's how we find the interquartile range, right? So you already worked out the upper quartile, we got 4.3. So we need to figure out what is the lower quartile. My lower quartile, in order to do that, I need to read off at 25 because a quarter of 100 is actually 25. So you're going to come across here, and what I'm going to get here is I'm getting about maybe 2.3 grams. Sorry, yeah, 2.3 grams. So what I'm getting here is Q1 is equal to 2.3 grams, right? That's what I'm getting for Q1. Now, what we need to do, we need to find our interquartile range first. So our interquartile range, IQ, right, is simply equal to Q3 minus Q1, right, which is, what do we got for the upper quartile? So that's 4.3 minus 2.3, right, and that's going to give me 2.0, right? So that's my interquartile range. So the question wants, in this part here, they want semi-interquartile range. So I need to take 2.0 and divide it by 2, and I'm going to get 1.0 as my answer, 1.0 gram, right? That's my interquartile range. All right, so now the next part of the question, so like I said, typically how they would ask the question, they would give you a table and they would ask you to actually come up with a cumulative frequency table, then come up with a cumulative frequency curve, right? But this particular question, they wanted us to do it in the reverse manner, right? So they said, using the cumulative frequency curve, complete the frequency table, right? Now, this is frequency they want here. Note what they want frequency, right? Now, our cumulative frequency always gives us data that is saying less than, right? Just remember that. That's what the cumulative frequency curve is doing. And it's giving us cumulative frequency. So if I read off, let's say in my table, look at the table here, this first table here, right? This here represents my upper class boundary, right? That's 2. So when I go to the table and I read off 2, you realize, wait a minute, that is corresponding to 20 students. So 20 students basically estimated the mass to be less than 2 grams, right? So less than 2, so that's how they got 20 as this figure here. Now our next upper class boundary will be 4. So let's look at this here. When we go back to the table and we read off 4, right? This 4 we're talking about here. You realize you're getting 68 students, right? So that's 68 students basically got a mass that was less than 4 grams, right? So therefore, in order to figure out, so this was 68. So in order to figure out, now that 68 includes our 20 as well, right? So therefore, this figure here should really be 48 grams, right? That's what that figure is supposed to be, right? Now this particular question required a little thinking, so you got to be careful how you're doing this question, right? So that is for this one here. The next value we need to read off from the graph the 6.0. So you go back to the graph and you're going to read off 6.0. According to this graph here, that looks like that is 93, right? That's what I'm looking like I get in there, right? So I'm getting 93. But remember that graph is giving me cumulative frequency, right? So that 93 actually includes the 20 and the 48. So therefore, to figure out what I'm going to put in the table here, it's going to be 93 minus 68, right? And that is going to give me 25. Now let's make sure that's correct there. So when I add up all these figures, I should get 100. So 20 plus 48 plus 25 plus 6 plus 1. Right, I'm going to get 100, right? So this is how we're going to complete the table here. The next part of the question, a student is chosen at random, right? Find the probability that the estimated mass is greater than 6 grams. So here's what you need to do for this question. You need to go to your graph and you need to figure out where 6 grams is located. That's 6 grams here, right? And when you measure that, that's one of the measurements we took just now. We got 93 students, right? So mass less than 6 grams, right? From the graph, I'm getting 93 students, right? But the thing is, the question asks for greater than, right? Pay attention to this. It's greater than, right? And I told you just now that this graph only gives me less than. So therefore, if we want to work out how many students actually estimated more than 6 grams, so mass more than 6 grams, right? That is going to be 100 minus 93, which is going to give me 7 grams, right? So the probability that they are asking me for here, right? That probability is going to be 7 over 100, right? So the answer, that is the probability that they want, and that is greater than 6 grams, is going to be 7 over 100. All right. Now I know some of you guys watching this live on Facebook, right? I just realized something here, that the diagram or the image that you are seeing is slightly smaller. So you're not seeing my full screen for some reason, right? So those of you watching on Facebook, what you can do, you can switch to YouTube. It's also being streamed live there as well, right? So next question. So that is January 2020. That's the cumulative frequency question, right? Now we have a next question here that you guys need to be able to do as well, and they want us to solve this pair of simultaneous equations, right? So in this first equation, we have y squared plus 2y plus 11 is equal to x, and then we have x is equal to 5y, so 5 minus 3y, right? Now, these are not two linear equations. So what we're going to do is we're going to label our equations. Let's label equation 1, equation 2, right? And what I'm going to do, I'm going to substitute equation 2 into 1. So substitute equation 2 into equation 1. That's what I'm doing, right? So this is going to become y squared plus 2y plus 11 is equal to 5 minus 3y, right? So this is looking like a quadratic to me. So it's going to be y squared plus 2y plus 3y plus 11 minus 5, right, is equal to 0. So all I've done, I've taken everything on my right hand side and carried it across to my left hand side, right? So this here now is going to be y squared plus 5y, right? And 11 minus 5, that's going to give me 6, is equal to 0, right? So now we have a quadratic that we need to be able to factorize, right? And this, when I factorize this, I'm going to get y plus 3, y plus 2, right? So now we can say either, remember you're trying to solve a quadratic here, right? So you have two solutions. So either y plus 3 is equal to 0, so y is equal to minus 3, or my second solution could be y plus 2 is equal to 0, and therefore y is equal to minus 2, right? But we need to go and find the x values now. So we're going to say x is equal to 5 minus 3 multiplied by y, which is minus 3. And that's going to give me 5 minus 3 multiplied by minus 3 is going to give me plus 9. And I'm going to get 14 here, right? And then we're going to get the other solution, which would be 5 minus 3 multiplied by minus 2. And that's going to give me 5, 3 2s are 6, that's plus 6. And that's going to give me 11, right? Right? So the solutions are x is equal to 14, right? And y is equal to minus 3. That's one solution. And the other solution is x is equal to 11 and y is equal to minus 2, right? So those are my solutions to this, this pair of simultaneous equations, right? So you have to be able to do this in the exam. Here's another one, right? We did something like this yesterday. So we have a quadratic function here. They've given us a quadratic function, 4x squared minus x minus 2. And the first part they want us to do, they want us to express this in this format. Now in yesterday's session, I showed you two methods in which we can do this, right? So let's start off. Let's go with 4x squared minus 8x minus 2, right? Essentially what we are doing, we are completing the square, right? Now what I could do here, I can first remove this 4, right? This is the second method I showed you guys yesterday. So this is x squared minus, let's get my eraser, this should be 2. So this is 2x, right, minus a half, right? So what I've done, I've factored out the 4 here, right? Now I'm going to try to complete the square. So leave the 4 on the outside, right? And like I told you yesterday, it's going to be x minus half of this value here. So this is 1. I'm going to square this, right? What you're going to do, you're going to write back your minus a half and then subtract this number here squared, right? So minus, well, 1 squared is going to give me 1. Close brackets. So what this is going to be now is 4, open brackets, x minus 1 squared. And basically minus a half minus 1 is minus 1.5, which is going to give me minus 3 over 2. So this here is minus 3 over 2. Next thing we're going to do now, we're going to multiply everything by the 4. So we're going to end up with 4 multiplied by x minus 1 squared, right? Minus, and this is going to give me 6, right? So this is what we're going to get when we complete the square. All right, see somebody from Jamaica saying, because of your videos, I pass maths. Cool, that's great. All right, big up Jamaica here. Let's see, where am I? Guys, just give me 1 sec, right? Just give me 1 sec. I just want to change something. I just need to fix something. Just give me a sec here. I'm just fixing something, right? All right, we should be good here. Let me see this. All right, so we're good. Right, so let me just show you the second method that I showed you guys yesterday, right? If you remember what I did. Right, I said what we could do, we can say put 4x squared minus 8x minus 2, and we're going to put it equal to a open brackets x plus h squared, right? So what we can do this. So this is x plus h squared plus k, right? That's one option we can do. All right, now if we expand the right hand side, we can end up with a, and this is going to be x squared plus 2hx plus h squared plus k, and then when we simplify this, you're going to get ax squared plus 2ahx plus h squared plus k, right? So this is one way. Another way we can do this question, right? So this is 4x squared minus 8x minus 2, 4x squared minus 8x minus 2. And what I told you guys yesterday, I said we can compare coefficients. Right? If we do that, then we can say easily that a is equal to 4. So a is equal to 4. We can see that if we compare in coefficients. The only term on the right hand side we have in x is this, and we have minus 8 here. We have minus 8x. So what that means is that 2ah is equal to minus 8, right? But a is 4. So this is 2 multiplied by 4. H is equal to minus 8. So therefore h is equal to minus 8 over 8, which is giving us minus 1. And notice that's what we got before. We got minus 1 before. Next thing we need to do, we need to find what k is. So this here is what we're left with, and that is equal to minus 2. So we're going to put a h squared plus k is equal to minus 2. But you know what a is? A is 4, and h is minus 1, right? We're going to square that plus k, and we're going to get minus 2, right? So minus 1 squared is 1, multiplied by 4, you're going to give us 4. So therefore, k is going to be equal to minus 2 minus 4. Therefore, k is going to be minus 6, right? Which is what we got here. So these are just two different ways. This is one way, right? And this is a second way we can do this first part here. Now, there are advantages to when we complete the square, right? Now, they want us to state the minimum value of the function. The minimum value of the function, once it's written in this format here, is simply k, right? So you don't have to do anything. There's no calculation here. The answer is simply minus 6. Because look, that is what we have here. We have minus 6. That gives us the value, the minimum value of our function. And the next one here, they want to know the axis of symmetry. Yesterday I showed you guys what to do. Whatever is inside this bracket here, this x plus h, you need to put that equal to 0 and solve for h. So therefore, it's going to be x minus 1 equal to 0. So therefore, x is equal to 1. So the answer for this here, for the axis of symmetry, is simply x is equal to 1, guys. Right? Now, the next thing you guys need to be able to do, right? Those of you who do in physics, you're going to find this very easy. But they've given us a speed time graph here, right? And they've given us a speed time graph over a period of 40 seconds. Now, there are a few things that you guys need to be able to know from this, right? When you have a speed time graph, right, there are two things they can potentially ask us. They can ask us to find our acceleration. That's one thing they can ask us to find, acceleration, right? And they can also ask you to find distance traveled. Those are two things that CSEC can ask us to find, acceleration or distance travel. If we want to find acceleration, let's say in this first stage of the journey here, this line here, all I need to do is to find my gradient. That is what we do to find acceleration from a speed time graph, right? So acceleration is simply gradient. That's what that is, right? When they ask you to find distance travel, let's say in stage 1, is simply the area under the graph, right? So from a speed time graph, if you want to get distance travel, it's simply area under the graph. So that's something you guys need to be able to do, huh? So that's the area under the graph. Now let's see what CSEC wants us to work out here. They said for determine the acceleration for each of the following stages. So the first one is stage 2, and they want acceleration. So stage 2 is actually here, which means that it's this horizontal line here, right? Now that part requires no calculation because the gradient of a horizontal line is 0. So the gradient of this, right, is equal to 0. That's the gradient is 0, right? So therefore, when they ask you for the acceleration in stage 2, so you're going to tell them acceleration, right, is equal to 0 meters per second squared. That's my unit for acceleration, by the way, guys. It's meters per second squared. Then in the third stage, they want us to find the acceleration again. So that's this line here, this sloping line here. So because of how this line is sloping here, I already know that that line has a negative gradient, right? Now, yesterday I gave you all a formula to find gradient. So all we need to find the gradient, we need this point, the coordinates of this point here, which is actually 32, 12. This point here is 40, 0, right? And we can find the gradient. What we do, like I told you all yesterday, what I typically tell my students to do is to label their points, right? So if we call this x1, y1, and then I'm going to call this x2, y2, then my gradient is simply equal to y2 minus y1 over x2 minus x1. That's the formula for gradient. So all I'm going to do now is substitute values. So y1 is actually 12, so it's 12 minus 0 divided by 32 minus 40, right? So 12 minus 0 gives me 12, and 32 minus 40 is going to give me minus 8, right? So that's going to give me a gradient of minus 3 over 2. So that's my gradient. So therefore, my acceleration, so you're going to tell them that, right, is simply equal to minus 3/2 meters per second squared, right? That's what my acceleration is, right? So you have to be able to find the gradient of these things. Right, so moving on. So this is also from a recent paper. You guys need to be able to use our circle theorems in order to solve angles in a particular diagram, right? Now, if you want to get some more information on this, you can actually just look through my YouTube channel and you'll get some information there in terms of all the rules that you need to know. So they've given us a circle here and they've given us some lines in the circle. And the first thing they want, write down the mathematical names for BC. What is BC? So the line BC is touching the edge or the edges of the circle. So you have B here and you have C here. So therefore that line that is joining B and C, that is called a chord, right? That's what we call a chord. The next thing, they have OA. That's this is A and this is O, which is the center of the circle. So therefore OA has to be the radius of the circle, right? So they're trying to see if you know the terms, right, when it comes to the geometry of a circle, right? Next thing, what do they want here now? So they want you to figure out the angles X and Y, and they want you to give reasons to support your answer. So guys, please, I want you all to remember that when you all are working out these questions, they typically ask you for a reason. So you need to know your circle geometry theorems, right? So you need to state it at some point in time. So the first thing we want to get the angle X, right? Now, here's what's happening here. This angle here is 37 degrees. The line OA here is a radius, but the line OB is also a radius. So that means that this length here and this length here, they're the same. So if this angle is 37, it also means that this angle here has to be 37 as well, right? So this angle here has to be 37 degrees as well, right? Now, if that is 37, then we can easily figure out what angle X is. So angle X is simply equal to, right, when you add up the internal angles of a triangle, it adds up to 180. So this is going to be 180 degrees minus 37 plus 37. Right? So you just use your calculator quickly for that. So that's 180 minus, and you're going to get 106 degrees. So that's my angle here, 106 degrees. Right? The next thing we're going to work out now, we want to figure out, the second part of the question here is finding out what is angle Y. Right? Now, you're going to have to use some of that circle geometry theorems we're talking about here. So the line BD, that's this line here, BD, it passes through the center of the circle, so it's a diameter, right? Now there is a rule that says the angle in a semicircle is 90 degrees. So because BD is a diameter, it means that this angle here is actually 90 degrees. That's what that means. So if you look carefully, you realize, wait a minute, but I can solve for Y easily. So Y is simply equal to 180 degrees minus 49 degrees plus 90 degrees, right? So that is 180 minus 49 plus 90, and I'm going to get 41 degrees, right? So that's my angle Y. So moving on, right? Most of these questions are from recent papers, so they may have been 2020, 2019, right? All right, so guys, you all need to be able to do a question on bearings if you see a question on bearings. Huh? So let's see how we can do this. The diagram below, not drawn to scale, shows the route of a ship cruising from Palm City, that's P, that's here, right, to Caton, that is down here, right, and then to Rivertown. So this is here, this is Rivertown, right? So that's the route of a ship. The bearing of Q from P. Now, you all need to understand this terminology. So the bearing of, that's how we typically write statements concerning bearing. The bearing of Q from P. Now, when we say from P is where I'm going to draw my north line, right? So at the point P, that's this point here, I'm going to draw a north line. That's what it did. So this is a north line here, right? And the bearing of Q is, we are traveling to Q, so Q is here, right, is given by this bearing here, right? So you need to understand the language that we're using. So the bearing of P from Q, the bearing of Q from P is 133 degrees. And they told us that angle PQR is 56 degrees. So that's this angle here. Now let's see what they want us to work out. So the first part, they want us to work out the angle W. So let's go to that diagram and see if you can figure out that angle W. Right? Now, I want you all to remember, when you are doing a bearings question, every north line that you draw, all of those north lines are parallel to each other. That's an important concept because you're going to need it in order to figure out certain angles. So look, you have a north line here. You also have a north line here, which means that those two north lines are parallel, right? And there's a rule in maths that says that this angle here, the 133, and this angle here, right? Those are what we call cointerior angles. So this particular angle here, right, is simply equal to 180 degrees minus 133 degrees, right? And that's going to give me 47 degrees. So I already know that this angle here is 47 degrees. Now, if you know this angle here is 47 degrees and this is 56, we can easily figure out what W is, right? Because this is a straight angle here. So W is equal to 180 degrees minus 56 plus 47, right? And you're going to get minus 56 plus 47, and you're going to get 77 degrees, right? So we just worked out this angle here and we got 77 degrees, right? So this here is 77 degrees. The next thing they want us to work out, determine the bearing of P from Q. So look at the language again, the bearing of P from Q. Now the from Q is where we're going to draw your north line. So this is going to be, so draw my north line at that point, right? So the bearing of P from Q. So let's see which angle they want us to work out here. The bearing of P from Q. So we are drawing our north line here at Q, and the bearing of P from Q is this angle that they want. So they want this angle here. That's the angle that they want, right? So if you look at this diagram, now it's just about angles here we're looking at. From this point here to this point, from this point here, this part here is 180 degrees. So the bearing of P from Q is simply 180 plus W plus 56. So it's 180 plus 77 plus 56. So for this one here, right, it's 180 degrees plus 77 plus 56. Right, and whatever we get there, let's see, that's 180 plus 77 plus 56, and you're going to get 313 degrees. Right, that's what we're going to get. So let's work the third part now. They want the distance RP. So let's go back to this diagram here, and where is RP? So RP is this distance here. This is what they want us to work out. Now, whenever you get a bearing question, right, most of the times what they expect you to use, you are going to either use the sine rule or the cosine rule in order to solve one of these questions, right? So if we look carefully at that triangle here, right, you realize that we have two lengths, that is 210 and 290, and we also know the angle between them, which is 56 degrees, right? This is one of those conditions in which I must use my cosine rule, right? So let me just draw a little quick sketch here so you can see what I'm saying here. Now we use the cosine rule under two different conditions, right? If we know all the sides of the triangle, we can use the cosine rule. So if we have the sides and no angle, we can use the cosine rule. So this is PQR, this is Q. Let's put it in here so you can see what's going on. So this is 210. This is 290. Right? And this angle here is 56 degrees. So this is 56 degrees, right? Now, we're going to use the cosine rule, right? Because I use the cosine rule when I have only three sides, or if I have two sides and the angle between them. So using the cosine rule, right? Now, what I typically do, I write the cosine rule in terms of the labeling that they've given us here. So we usually start up the cosine rule with the side opposite the angle squared. So it's going to be RP squared is equal to, I'm going to square the other two sides. So that is 210 squared plus 290 squared. And then in the formula, it's minus, and you're going to put 2 multiplied by whatever this length was, which is 210, multiplied by whatever this length was, which is 290, multiplied by cosine of the angle, which is 56 degrees, right? So I try to let my students not necessarily learn off the formula. I want them to understand what you are actually taking from the triangle, right? So now all we're doing here is we're going to work this out. So RP squared, right? Now, some students, they can work this out in one go, right? And that's fine once you don't make a mistake. So this here is going to be 44,100, right? I'm just going to write it out to make sure I don't make a mistake. So this is 290 squared, and that's 84,100. So this is 84,100 minus, and then you work out everything inside the bracket. So that's 2 multiplied by 210 multiplied by 290 multiplied by cosine of 56 degrees. What I'm going to get here is 68110, right? I just rounded it off there. So therefore RP is equal to, RP squared, sorry, is equal to 44,100 plus 84,100, and then I'm going to subtract 68,110, and what I'm going to get is 60,090, 60090. So therefore RP is equal to the square root of that, 60090. So therefore RP is equal to, you're going to find the square root of this, right? And what I'm going to get as my distance is going to be 245 kilometers, right? So that's the distance here for RP. All right, so moving on, I'm just trying to do as much questions as I can do any time slot that I have here, right? This is also a recent question as well, right? So oddly enough, this is CSEC brought a similar question to this in the past, right? So we have two triangles, right? Two rectangles, a small rectangle and a bigger rectangle. The area of the larger rectangle, which is ABCD, is 44, right? And they've given us some dimensions there as well. They said by writing an expression for the area of rectangle ABCD, show that this is true, right? So many students sent me questions concerning this, right? And this is pretty straightforward. So the area of ABCD is 44 centimeters squared, right? So let's first find the dimensions of this rectangle, the larger rectangle. So this here, right, the length AB is actually 2 plus 3x. So this here is 2 plus 3x, right? Hold on one second, guys. Yeah, so AB is equal to 2 plus 3x, and BC, that's this length here, right, is actually equal to, look, it's 3x plus 4. So this here is 3x plus 4, right? Now, to find the area of a rectangle, it is length by width or length by breadth, right? So what we're going to do, we're going to multiply those two lengths. So what we're going to have here is 2 plus 3x, right, multiplied by 3x plus 4. But when we work that out, we know that the area should be equal to 44, right? So this is our starting point to be able to show this, right? Now, how do we multiply those two brackets? So what we do, we're going to take the first term here, this 2, and we're going to multiply it by everything in the second bracket. That's what we're doing, right? So 2 multiplied by 3x will give me 6x, and then 2 multiplied by 4 is going to give me 8. So this is 6x plus 8. The next thing we're going to do now, we're going to multiply this 3x by everything in the second bracket. So that's 3x by 3x and then 3x by 4. Now, what is that going to give me? So 3x by 3x will give me 9x squared. So this is 9x squared. And then 3x by 4 is going to give me 12x, which is going to give me 44, right? So now let's try to simplify this thing. So we have 9x squared. I'm just putting that first, right? Plus 6x plus 12x plus 8, right? Minus 44 is equal to 0. So all I'm doing is carry everything to the left hand side. So I'm going to get 9x squared, right, plus 6x plus 12x is going to give me 18x, right, and 8 minus 44 is going to give me minus 36. So this is minus 36 is equal to 0. So therefore, all we need to do is to divide everything by 9. If I divide everything by 9, I'm going to get x squared plus 2x minus 4 is equal to 0. And look, that's what they asked us to prove, right? So this is how we prove something like this in the exam. Right, now they want us to calculate to 3 decimal places the value of x, right? Now, look at the equation that we have. We have x squared plus 2x minus 4. So we have x squared plus 2x minus 4. That's what we have, right? Now, this here is a quadratic, and the fact that they told us to solve this to 3 decimal places, that gives us a hint, right? So whenever CXC tells you to solve a quadratic and they say to 2 decimal places or 3 decimal places, it means that they want us to use the formula, right? Or we could complete the square in order to solve this, right? It means that this quadratic is not going to factorize. So what you will have to do, I would use my formula in this particular case. So a quadratic function looks like this: ax squared plus bx plus c, right, equals 0. Now, in this case, what that tells me is that a is equal to 1, b is equal to 2, and c is equal to minus 4, right? That's what that means. Now, there is a formula to solve a quadratic, right? And the formula looks like this. And by the way, you are given this formula in the exam. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. That's the formula to solve a quadratic. And we know what A is, we know what B is, and we know what C is. So all we're going to do, we're going to substitute. So this is minus 2 plus or minus B squared. So this is 2 squared minus 4 multiplied by A, which is 1, multiplied by C, which is minus 4. And then we're finding the square root of all of this, and then we're going to divide by 2 multiplied by A, which is 1. Right? So you're going to have to take your time and work this out. So this is minus 2 plus or minus, and let's work out what should go under the square root sign. So 2 squared is going to give me 4, right? So that's 4 minus 4 multiplied by minus 4 is going to give me plus 16. So that's 20. So what I'm getting here is 20. So this is square root of 20 divided by 2. Now when you solve a quadratic, right, you could potentially get two solutions. So here's what we're going to do. We're going to say either, right, x is equal to minus 2 plus the square root of 20 divided by 2, and you're going to work out that. So that's minus 2 plus square root of 20 divided by 2, and I'm going to get 1 point, they said 3 decimal places, right? So I'm going to put 1.236, that's one value, or you can get x is equal to minus 2 minus the square root of 20 divided by 2, and what I'm going to get here is minus 2 minus square root of 20 divided by 2. I'm going to get this minus 3.236, right? So these are my two values here. So please make sure you know how to solve a quadratic using the formula. The next thing I want us to do is to find the perimeter of the unshaded area, right? Now, the unshaded area from our diagram, right, that's this white piece here they're talking about here, right? That is essentially the area of the whole rectangle, the big rectangle, minus the area of the small rectangle. So let's see, that's what I want, right? Unshaded. Oh no, sorry, they want perimeter, not area, right? I read it wrong. So they want the perimeter of the unshaded region, right? Now perimeter is distance around something. So that is this length here plus this length here plus this length here plus this length here plus this length, because perimeter we're talking about, right? Plus this length here, right? So we're gonna add that up here. So that is going to be, so perimeter is equal to, and from the diagram we're going to say AB plus BC. So that is AB plus BC plus CE. AB plus BC plus CE plus EF plus FG. Plus EF plus FG, right? All I'm doing is I'm going around the shape, you know, that's all I'm doing. Plus FG plus GA or AG. Right? That's what I'm doing. So let's write down what we know. So AB, according to the diagram, is 2 plus 3x, right? So you're going to put that. So AB is 2 plus 3x, right? That's what AB is. Plus BC, 3x plus 4. So this here is 3x plus 4. One second, guys. Just give me a sec. It's on your phone. Plus CE, right? What is CE? CE. So CE is 3x. Plus EF, let's go back to the diagram. What is EF? EF is 4 and FG is 2. So that's 4 and that's 2. Plus AG. AG is 3x, right? So all I need to do is to kind of simplify this here. Let's add all our x's together. So we have 3x plus 3x is 6, plus 3 is 9, and 3, that's 12x. So that's 12x plus, let's add up the whole numbers now. So 2 plus 4 is 6, and 4, 10, and 2, 12. So that's 12x plus 12. But the thing is, you just worked out what x was. You got two values for x. But the one that we're going to use this one here, the positive value, because it can't have a negative length, right? So that is 1.236. So that is 12 multiplied by 1.236 plus 12. And what I'm going to get is 26.832. Right? 26.832. Alright, so I think that question came from the June 2019 paper. Right? So this question here, this is from June 2019, right? All right, so let's take a look at this question for a sec. Just give me 1 second. I just need to check something. Okay, so this next one here, let's see, was that 2019 as well? No, I think that may have been 2018, I think, right? So let's look at this question here. So we have a circle again, right? They're telling us that AC is the diameter, B and D are 2 points on the circle. So basically this information here is what we are seeing on the diagram, right? And the first thing they want us to do is to find angle DBA. Now when you have questions like these, what you should do is to look at the diagram and try to figure out what angle are we looking for. So DBA, this is my angle here, right? We're looking at DBA. So where is D? D is here, this is B, and this is A. So they want this whole angle here, right? This whole angle here, this is what they want, DBA. Now, when you have questions like these, right, you're going to have to use your circle geometry rules or theorems, right? Now, AC is a diameter, right? Which means what we can say is that angle ABC has to be equal to 90 degrees. That's what that means, right? So therefore, if we want to get that angle they want us to find, which is DBA, so angle DBA has to be equal to 90 degrees minus 46 degrees, right? That's how we're going to get that angle. So it's 90 minus 46. And what I'm going to get here is 44 degrees, right? So that's my angle here. Now, what I suggest you do, every angle that you work out, you should try to put it on the diagram one time. So this here is 44 degrees. So you're going to put it on the diagram so it'll help you work out the question, right? So that's my answer for part 1. And please, these questions typically go for like 2 marks, and they want the answer and they want the reason. So the reason that we use there is that the angle in a semicircle is 90 degrees, right? That's my reason. That's what I'm telling them. So if ABC is 90 degrees, then DBA is simply 90 minus 46 degrees, right? Next one, they want DAC. So where is DAC? DAC is this angle here. That's what they want here. Now, there are different rules, right, guys? So look at something here. In order to form DAC, we must use the point D, we must use the point C, and obviously we're using A, so the angle is at A. But if you look carefully, if we use the same point D and the same point C, and I come to the circumference of the circle, I am getting this angle here, which is 46 degrees. So there is a rule that says that this angle here should be 46 degrees as well, right? So my answer for angle DAC, right, is equal to 46 degrees. And the rule that we're using there is that angles in the same segment are equal, right? That's the rule that we're using. So when they ask you for the reason, that's the reason that you are giving them, right? Now, what angle they want us to work out now? BCE. Where is BCE? So angle BCE. All right, so angle BCE, look at where they want this angle here, right? That is angle BCE. Alright, so you want to get this angle here, right? Now you have to look at the diagram carefully, right? So when you get these questions, you kind of have to pull information from different things you would have known in maths already. Now, look at something here. A and D, they are a chord, right? And it's forming an angle of 44 degrees with B here, right? Now what that tells me is that, you see this angle here? This angle here is also 44 degrees, right? And that is because I'm using this point A and D and B to form this angle 44 degrees. I'm also using the point A, D and C, and therefore this angle has to be 44 degrees, right? So we're almost there. So if I know what this angle is here, I can easily figure out this, which is what I want to find, right? And you can't do that because look, you have a triangle here. This triangle A, B, C, right? You know this is 28. You know this whole angle here, right? That is 90 degrees. So therefore I can figure out this angle here. So let's do that. Let's find ACB. So angle ACB, right, is equal to 180 minus 28 degrees plus 90. And let's see what I'm going to get here. So that's 180 minus 28 plus 90, and that's going to give me 62 degrees, right? So this angle here is what I just worked out. That's 62 degrees. So this here is 62 degrees. So you know this is 44, you know this is 62. Well, this we can work this out easily now. So that angle there is simply going to be 180 minus 44 plus 62, right? So that's 180 minus brackets 44 plus 62. And what I'm going to get there is 74 degrees, right? Alright, so we have our next question here. Alright, so just a reminder again, guys, right? So anybody who's looking for CSEC maths lessons online or CSEC chemistry or CSEC physics, right? You can contact me at this number here, 868-784-2059, right? Especially if some of you all are writing exam in May, June this year, right? I am in exam preparation mode for basically all of those classes, right? So part B of that same question here. So we have a diagram. The diagram shows a quadrilateral. A quadrilateral is a four-sided figure, right? And they said that PQ and SR are parallel. So this is PQ and this here is SR. So therefore this quadrilateral that we are talking about here is actually a trapezium, right? That's what it is. So the first part, they want us to figure out what is the length PS. So PS, as this length here, that's what they want. right? Now, how are we going to do that? Let's see. Now, the fact that PQ and SR are parallel, it means that this angle here has to be 90 degrees, right? So if here is 30 degrees, it means that this angle here is 60 degrees, right? And it also means that this angle here has to be 30 degrees, right? So basically, I have a right angle triangle, which is PSQ, and I want to be able to figure out what is PS, right? So there are different things that I can do here, right? When it comes to right angle triangles, guys, you need to remember this. SOH, so, ka, tua, right? What does that mean? It's an acronym to allow us to remember how do we find sine of an angle, cosine of an angle, and tangent of an angle. So sine is opposite of hypotenuse, cosine is adjacent of hypotenuse, and tangent is opposite of adjacent, right? If you want more information or more questions concerning this, just do a search on my YouTube channel here and you can find any video concerning those things, right? So let's see, what am I going to use? I want to get the length PS, right? Now, in a right angle triangle, the side opposite my right angle is called my hypotenuse. So this is my hypotenuse. Now, your opposite is going to be determined by whatever I choose as my angle to use. So if I use 30 degrees in my calculation, it means that this side here is my opposite, right? So if that's my opposite, it means that this length here is my adjacent, right? So let's see, can we do, right? So I know what my angle is, I know what my hypotenuse is, and I have opposite. So therefore, if I have opposite and hypotenuse, then what I should use sine, right? So let's write that out. First thing we do, we say sine theta is opposite over hypotenuse, right? That's the first thing we're going to say. So sine 30 degrees is equal to my opposite, which we don't know, which is PS. So that's PS divided by my hypotenuse, which is 8, right? I'm going to put the sine 30 over 1, and what I'm going to do, I'm going to cross multiply. So PS multiplied by 1 will give me PS, and then this will be 8 multiplied by sine 30 degrees. So all I'm doing here is just using my calculator. So 8 multiplied by sine 30 degrees, and I'm going to get 4 centimeters, right? So that's my length there. PS is equal to 4 centimeters. What else do they want us to find? They want us to find the length PQ. So where is PQ now? Right, so PQ is this length on top here, right? PQ is this length on top here. Now, we can use trigonometry to work out PQ because we have, we know this is 4 centimeters here, right? We also know this is 8 centimeters. So we can use one of our rules, or we can simply use Pythagoras Theorem because it's a right angle triangle and we know some dimensions here. So let me make sure you're seeing what I am saying. This is what we have, right? This here is 8 centimeters. This here, we just worked this out and we got 6 centimeters. That's what we got, right? 6. No, not 6. We got 4 centimeters. We got this as being 4 centimeters and we don't know what its length is here, right? Which is PQ. This is PQ. So what I can do, I can use Pythagoras' theorem to figure out PQ, right? So like I said in class, I don't normally tell my students to just learn off a formula. So this is my right angle here, right? And it's always the hypotenuse squared is equal to the sum of the squares of the other two sides. So PQ, using Pythagoras' theorem, PQ squared plus 4 squared is equal to 8 squared, right? So PQ squared is equal to 8 squared minus 4 squared. So PQ squared is equal to 8 is 64 minus 16. PQ squared is equal to, this is going to give me 48, right? So PQ is equal to the square root of 48. So PQ, and that's going to give me 6.9 centimeters. 6.9 centimeters. So that's what PQ is, right? And then the last part, calculate the area of PQRS. So what is PQRS? So this is PQRS, right? They want us to calculate the area of this trapezium, right? Now there is a formula to work out the area of a trapezium, right? And it is half the sum of the parallel sides multiplied by the distance between the parallel sides, right? So I can easily find the area of the triangle, right? But what I should do, I should find this length SR first of all, right? I should find that length SR. For this triangle here, let's work out this angle here, right? This is 30 degrees here. This is 82 degrees. So I can work out this angle easily. That is 180 minus, open brackets, 82 plus 30, and I'm going to get 68. So this angle here is 68 degrees, right? Now, if I want to get the length SR, so that's what I want to find first, right? I want to find the length SR. So let's just draw over this quickly. So remember, the diagram is actually a trapezium, right? Now the area of a trapezium is given by this. If I know these dimensions of the trapezium, then my area is equal to a half by A plus B multiplied by H. So please, you need to know this. They ask this question almost every year in the multiple choice, how to find the area of a trapezium, right? So based on what we know on the diagram, we already know what H is. H is 4 centimeters. We also know what PQ is. PQ is 6.9. So the only thing we don't know is this length here, right? But this is what we do know. So this here is 8. And in terms of angles, we have 82, 30, and 68. So this is 82. This is 30. And this here is 68. Right? What are the, right? So we look at this. We have all the angles inside the triangle. We have one side here, right? Let me just label this. So this is P, Q, R, and S, right? Now if I figure out what SR is, then it's easy for me to work out the area of the triangle. What I can do, I can use my sine rule, which is different to cosine rule, guys, and it's different to using your sine ratio. So we're using the sine rule, right? That's what I'm going to use. So I want to get a length B, which is SR. So in terms of the sine rule, I can write SR divided by sine 82 degrees is equal to 8 divided by sine 68 degrees, right? Again, if you want more information about the sine rule, just do a quick search on my channel, and I should have a video explaining how to use the sine rule and the cosine rule. So all I'm going to do is cross multiply. So SR is equal to 8 multiplied by sine 82 degrees divided by sine 68 degrees. So SR is equal to 8 multiplied by sine 82 divided by sine 68, right? And what I'm going to get is 8.5 centimeters. So this here is 8.5 centimeters, right? So therefore, if I want to find the area of the trapezium, it's going to be a half multiplied by 6.9 plus 8.5 multiplied by 4. So that is 6.9 plus 8.5 divided by 4. And what I'm going to get is 30.8 centimeters squared. one second, guys. Let me just check something here. All right, so let's see what question I have here for you guys again. All right, so our next question here, right? So this one here again is on bearings, right? So the diagram below, not drawn to scale, shows the relative positions of three reservoirs, B, F, and G, all on ground level. The distance between BF, or the distance BF, sorry, is 32. The distance FG is 55 and angle BFG is 103 degrees. So basically all the information that they've basically stated here, it's on the diagram, right? So let's see what they want us to work out. Determine the bearing of B from F, right? So therefore the from F is where I'm going to draw my north line, right? You'll have to remember this. So the bearing of B from F. So let's see where that bearing is. The bearing of B from F. So from F, it means that I'm going to draw a north line here, right? And the bearing of B from F is this angle, this whole angle here, right? Which is 103 plus whatever this other angle is here. Now, how do we do that? So first thing, let's draw back our north line, right? So this is my north line here. Now you have another north line that's across here. So if this is 42 degrees, I know exactly what this angle is here. That angle is 180 minus 42, right? So 180 degrees minus 42 degrees, right? And that's going to give me 138 degrees, right? 138 degrees, right? So this angle here is 138 degrees, right? So therefore, I can work out this angle here, you know. This angle there is going to be 360 degrees, right? Minus 138 plus 103. So that's going to give me 360 minus brackets 138 plus 103. And I'm going to get 119 degrees. Right? So this angle across here has to be 119 degrees, right? So therefore the bearing is this whole thing here from, I'm going to use a different color here so you can see what I'm talking about. So the bearing of B, this is where B is, right? From F is this whole angle here, right? So that answer is going to be for this part here. It's going to be 119 plus 103. So this is going to be 119 degrees plus 103 degrees. And that's going to give me 222 degrees. 222 degrees. Right? So that's the bearing for that one. That's the answer for this. Then in part 2 now, calculate the distance BG. Now, where is BG? So BG is this length here. This length here. That's what they want us to work out, right? Now, again, we have a triangle here. We have this length, and you realize, wait a minute, I have this angle here as well. So therefore, I can use my cosine rule in order to figure out what BG is. So using the cosine rule, it's going to be like this. BG squared is equal to 32 squared plus 55 squared minus 2 multiplied by 32 multiplied by 55 multiplied by cosine of my angle, which is 103 degrees, right? So therefore BG squared. So what you can do, you can use your calculator to work out each of those parts there. So 32 squared will give me 1024. So this is 1024 plus 55 squared, and that is 3025, right? Minus, and then you work out what's in the brackets. So that's 2 multiplied by 32 multiplied by 55 multiplied by cosine of 103. And what I'm going to get, now you got to be careful with these ones, right? Because I'm going to get minus 791.8. Notice I get a negative sign, right? So BG squared. Now you have two negative signs coming one after the next. So that means we're going to have to add it. So 1024 plus 3025 plus 791.8. And what I'm going to get is 4840.8. So therefore BG is going to be equal to the square root of 4840.8. So therefore BG, just use the calculator here. So square root 4840.8. And what I'm going to get is 69.6 kilometers. So that's 69.6 kilometers, right? So that's my answer for BG. So the next thing I want to know, calculate to the nearest degree the bearing of G from F. So the bearing of G from F. Let me make sure I read that correct, right? The bearing of G, the bearing of G from B, right? So read the question properly. It's like how I misread it. The bearing of G from B. So let's see what bearing they're talking about there. Bearing of G from B, right? So it means that I'm going to put my north line here, right? And the bearing that they want us to find there is this bearing here. They want this angle here. I know part of the angle already, it's 42. But I need to get what is this angle here. If I figure this out, well then I can work it out. Now, something to remember, when you get a bearings question, chances are you're going to have to use either the sine rule or the cosine rule or a combination of them, right? Now, to use the sine rule, I need to know what this side is, which I know it's 55, right? And we just worked out BG. We got 69.6 kilometers, right? And look, we have the angle that is opposite that as well. So that is enough information for me to use the sine rule, right? So in order to use the sine rule looks like this. I'm going to take a length, that's this, divided by sine of an angle, that's this here, equal to this length divided by this angle that we don't know. So I'm going to set it up like this. So using the sine rule we're using this time, right? It's not a right angle triangle. So it's going to be 69.6. So it's going to be 69.6 divided by sine 103 degrees is equal to, right? I'm using this length divided by the sine of this angle here. And then I'm going to use this length, which is 55, divided by sine of the unknown angle that I do know. So we're going to say 55 divided by sine 55 divided by sine of that angle we don't know, right? So with the sine rule, I'm going to cross multiply. So we're going to end up with sine theta is equal to 55 multiplied by sine 103 degrees divided by 55 divided by 69.6. So sine theta, right, is equal to 55 multiplied by sine 103 divided by 69.6. And what I'm going to get is 0.770, right? So theta is going to be, you're going to use a calculator to do this. right? And therefore theta is going to be, so second function sine, and that's going to give me 50.4 degrees, right? But we haven't finished the question as yet, because that 50.4 degrees is only this angle here. That's 50.4 degrees, right? So the bearing that they asking us for is this whole angle here. So that's 50.4 plus 42. So my answer, right, is 50.4 plus 42 degrees, right? And that's going to give me what, 92.4 degrees, right? That's going to give me 92.4 degrees. Hopefully I don't have a mistake there, right? So this is basically how we do a bearing question. Alright, so there's one more question that I want to do with you guys, and that has to do with angle of depression. So in the exam, you need to be able to do questions involving angle of depression and angle of elevation, right? So they said the person is at the top of a lighthouse, right? TB, so TB is my lighthouse, that's this, right? What else? And they said the angle of depressions are 12 degrees and 20 degrees respectively, right? So therefore, one second, angle of depressions are 12 degrees, right? And the ships are 110 meters apart, right? So this here, S1, this distance here, right, represents my 110 meters, right? So the angles of depression are, so one angle of depression will be here and one is going to be here, right? So in the case of S1, we're talking about 12 degrees. So this here represents 12 degrees and this whole angle here represents 20 degrees, right? So that's what we have. They said copy and complete the diagram by inserting the angles of depression. So that's what they want here. They probably give you like 2 marks for that. And they want the distance TS2 to the nearest meter. So TS2, where is that? TS2. So that's this length here. That's this length here. Now, what we can do, right? We can put in all the angles that we do know, right? So this is 20 degrees here. So if that's 20, I know what this angle is here already. This angle has to be 70 degrees. Right? Now, can that help us? Okay, right. So this is 70 degrees. So we know what this angle is here. This angle here has to be 20 degrees, right? So we know this. We also know this angle here. That has to be 160 degrees, right? So all you can do, put in all the angles that you can figure out on the diagram, right? We also can figure out this small angle here too. This small angle here is simply 20 degrees minus 12 degrees. So we know this is 8 degrees, right? So if I want to find that length TS2, right? What I can do, I can use the sine rule again to work this out here. So what I can say is that TS2 divided by sine 160 is equal to 110 divided by sine 8 degrees, right? So I'm using my sine rule here to figure out what TS2 is. So TS2, I'm going to cross multiply. It's going to be 110 multiplied by sine 160 degrees, right, divided by sine 8 degrees. So therefore TS2, and you just use the calculator. So that's 110 multiplied by sine 160 divided by sine 8 degrees. And what I'm going to get here is 270 meters. Right? Because they want the answer to the nearest meter. So that's my answer there, TS2. So that's this length here that we just worked out here. This length here is 270 meters. So that's this. And the last part, they want, what is the height of the lighthouse TB, right? What is the height of the lighthouse TB? Now, we can easily work that out as well, because, so they want to know this length here, right? You already worked out TS2, you got 270 meters, right? This angle here, right, is actually 70 plus 7, sorry, 70 plus 8, that's 78 degrees. So let me just draw this over so I don't confuse you. So this is what we know. So we said that this here is 78 degrees, right? This here, we just worked this out and we got 270 meters, right? And you want to get the length TB. That's T, and this is B, and this point here is S2, right? So this is S2, right? So basically we want to figure out what is this length here, and we know that this is a right angle triangle. So in terms of labeling a right angle triangle, this is going to be my opposite side. The side opposite the 90 degrees is always my hypotenuse. So therefore what I'm left with is my adjacent, right? So we want to figure out what the adjacent is, and I know what my hypotenuse is. So therefore what I'm going to use is not the cosine rule, I'm going to use the cosine ratio. So cos theta is actually adjacent over hypotenuse, right? So cos 78 degrees is equal to my adjacent, which we don't know, so that's TB, divided by my hypotenuse, which is 270, right? We're going to write the cos 78 as cos 78 over 1, so we can cross multiply. So TB is equal to 270 multiplied by cosine 78 degrees, right? So TB is equal to and what I'm going to get here is 56.1 meters. All right. So guys, so this brings me to the end of what I wanted to do today, right? I'm hoping that these 5 sessions did help a bit. And like I said, I do give online classes for maths, chemistry, and physics, right? So for everybody who's interested in those subjects, if you are writing it in May, then you can contact me at this number here, 868-784-2059, right? So I hope the 5 sessions were helpful for you guys, right? Obviously, you can't finish the entire syllabus in 5 sessions, right? So good luck for all of you who are writing next week, right? Hopefully you pull through, right? So take care, guys. I hope the session was productive. Afternoon, everybody.